Everybody, this is Jono from Seneca, and today I am going to be talking through collision theory for your A-level chemistry exam. We are going to be bashing through this topic and fighting our way to the end, and hopefully all of those knowledge points will smash together in your head and you'll leave this episode feeling ready to tackle your A-level exam. Okay, I'll stop with the extended metaphor now. No more collision metaphors, but it was a bit of fun to start the episode. Let's dive into the theory. So, collision theory is the theory of how reactions happen. When will a reaction happen? Well, for a reaction between two molecules to happen, they must come into close proximity with each other. For a particular reaction to happen, several conditions must be met. The correct part of the molecules must collide, and the molecules must collide with enough energy to react. Steric factor. Now, the steric factor, honey, that's just a fancy name for saying that the location of a collision matters. For example, if you were to react the OH bond in ethanol, a collision with the CH3 group wouldn't do anything. So that's what the steric factor is chatting about. Activation energy. The activation energy is the energy needed for a reaction to happen. It is used to break the bonds in the reactants before new bonds can be made in the products. For both reasons of activation energy and steric factor, most collisions do not result in a reaction. So, what does the steric factor, what is that? So that's just a complex phrase to describe how the location of a collision is important. Now, do we remember the two conditions for a collision to result in a reaction? The collision, first of all, needs to have enough energy for the reaction to happen. So that's the activation energy needs to be reached. Secondly, a collision needs to take place in the correct location within the molecule for a reaction to happen. And that is our steric factor. Next, we're going to talk about enthalpy profiles. Now, they show a progressive reaction on the x-axis and the energy level on the y-axis, and they contain the following information. First of all, the relative enthalpies of the reactants and products. It also shows the activation energy of a reaction and the overall enthalpy change of a reaction. For an exothermic reaction, the enthalpy of the reactants is higher than the enthalpy of the products, giving a negative enthalpy change, whereas for an endothermic reaction, the energy of the products will be above the energy of the reactants, giving a positive enthalpy change. Okay, so that's a really important difference to remember. Because remember, in endothermic reactions, energy from the surroundings is transferred to the reactant chemicals, so the energy of the products will be higher than the reactants. Whereas in an exothermic reaction, we give out energy to the surroundings, which is why they get warmer, and this means the products have less energy than the reactants. So a little quiz, see if you were paying attention. I'm sure you were. If we have an enthalpy profile where the products are above the reactants, what kind of reactions do we have? So the products are above the reactants, so we have endothermic. Because remember, endothermic, we take energy in from the surroundings, which is why they get colder. So our products are going to have more enthalpy than our reactants. Really important. And whenever you're drawing an enthalpy profile, which will be a lot during your A-level chemistry course, just FYI, always remember to draw the axes. And remember, the x-axis is the progress of the reaction and the enthalpy is the y-axis. And then remember 4 things: reactants, products, enthalpy change, and the activation energy. Always label those, especially in exam questions, because that's where you're going to get your marks. While we're here, let's go over that definition for activation energy again. Do you remember what it is? Well, it's the minimum amount of enthalpy that reacting particles must have in order for a reaction to occur. Holla, that is activation energy. Really important. Make sure you nail that definition now. It comes up a lot in A-level chemistry. Let's rewind it back a little bit. Do we remember the 2 conditions required for a reaction to happen? Firstly, the correct part of the molecule needs to collide, so that's the steric factors we're talking about. Secondly, the molecules must collide with enough energy to react. That is our activation energy. And then final question to finish, in an enthalpy profile, what do we draw on the x-axis? X-axis is progress of reaction and y-axis is enthalpy. Okay, that brings us to the end of this episode on collision theory. Make sure you keep on hitting through this module to make sure all of those points stick. And I look forward to joining you in the next episode.